I'm Anil Kumar. Welcome to my series on trigonometry. We'll discuss radian measures and angles on Cartesian planes in this particular video. This exercise is very useful for students who are taking up functions, and it is also very essential for pre-calculus. We'll begin with 5 multiple choice questions which you can see, and then take a few knowledge-based short answer questions which you can see here, question number 6, 7 and 8, and then we'll take up more word problems and techniques to solve equations. Now let's begin and solve these questions one by one. The very first question is, which of the following expression is positive? Cos of minus 1, sine of 2, tan of 3, and cot of 4. Now all these angles are in radians. So when degree sign is not given to us, then it is radians, correct? So let's remember one thing, that in our coordinate plane, as far as the radians are concerned, this is 0, that is pi by 2. This is pi, right? And this one is 3 pi by 2, correct? 3 pi by 2. Now we are talking about numbers 1, 2, 3, 4. We know pi is 3.14, right? So pi could be written as 3.14, correct? Because we need to figure out in which quadrant we are, correct? So that is pi. And what is half of 3.14? So if you divide this by 2, what do you get? You get 1, let me write here, 1, and then it becomes 11, so 1.5 gives us 10, and then we get 14, so that is Karib 8, right? So 1.58 maybe, right, will be approximately our pi by 2. Now if I add these two, we get what is 3 pi by 2. So if I add 8 and 4 is 12, which is 2, 1. 5 and 1, 6 and 1, 7, right? And 1 and 3 is 4. So around 4.72 is 3 pi by 2. So now looking into these angles, and let us also understand the rule that all are positive here. Sine is positive in quadrant 2, tan in 3, and cosine in 4. Now we are looking for positive expressions, correct? So when I say cos of minus 1, so 1 definitely will be in this quadrant. Here cos is positive. So which of the following expression is positive? Definitely this is positive, right? Since it happens to be in quadrant 1, right? So quadrant 4, which is right there, right? So that is positive. Sine 2 will fall here, and what we get here is that sine of 2, which is more than this, should also be positive. So this is also positive for us, correct? Now we are talking about tan of 3. Now tan 3 will be in this quadrant. Here tan is negative, so that is not going to be positive. Cotangent of 4. Now 4 lies in this quadrant. So here again cot is positive. So in this particular case, which of the following expression is positive? We actually have 3 expressions which are positive. So in my multiple choice questions, at times you may have answers which are more than one correct answer. Is that clear to you? Correct? So I hope that makes sense. Question number 2. Value of cos 5 pi by 3 is what? Now when we say 5 pi by 3, what do we mean? 5 pi by 3 means that is, this is pi by 3. Let's say this is pi by 3. That is 2 pi by 3, correct? This is 3 pi by 3. 4 pi by 3, right? And here we get 5 pi by 3. This is 6 pi by 3 or 2 pi. So 5 pi by 3 means we are in quadrant 4, right? So we are in quadrant 4, and that means we are looking for a positive value, correct? So the acute angle here is pi by 3. This is the acute angle, which is pi by 3. And we are in quadrant 4. So let's make our special triangle, right? So that is the special triangle for pi by 3, which you should all know. So for pi by 3, the sides are 1, 2, and square root of 3. We are looking for cosine, which is 1 over 2. So we get a positive half as our answer. Is that clear to you, right? So that is how we are going to answer this particular question. Question number 3. Express equivalent to cos pi by 2 plus theta. Now when I say cos pi by 2 plus theta, it means that we are in quadrant 2, right? So that is pi by 2, and some angle theta means we are here. Now in this quadrant, we know cos is negative. So we are looking for a negative value, right? So we are looking for a negative value, and that is a co-function. It has to be negative of sine theta. So option C is the right option, negative sine theta. Is that clear to you? So I hope these questions are absolutely clear. Now, question number 4. Expression equivalent to cos of 2 pi by 3 is what? Now this time we are looking into cos of 2 pi by 3. So let's again sketch the position of 2 pi by 3, which basically means we are in quadrant 2, right? So we are in quadrant 2. Cos is definitely negative, and the acute angle here is 60 degrees, or pi by 3, right? So that is 1 pi by 3, correct? So that is our related acute angle. Now when we are looking into an equivalent position right there, in that case, what do we get? Cos of 2 pi by 3 means, again, back to our triangle. If one angle is pi by 3, right, then the other is pi by 6, correct? So when we are saying cos 2 pi by 3, which is same as cos of 2 pi by 3 is same as minus of cos of pi by 3, correct? We don't have that minus of cos of pi by 3. However, we have minus of cos of pi by 6. See, pi by 3 is the ratio of this side over that side, correct? Now, if you look from sine point of view, then pi by 6 is the right answer, correct? So again, we get option C as the right option, negative sine pi by 6. Is that clear to you? Perfect. Question number 5. If cot x is equal to tan 1.2, the x is what value, right? So this is what we need to figure out. Now, that is, we're talking about co-function identity now. Correct? So we are saying tan x is equals to tan, cot x is equals to tan of something. So what we know here is that cot x is equal to tan of 1.2 is given to us. So 1.2 is the angle, right? So what should x be? All right, so that is what we need to find. So it is pi by 2 minus theta, right? So it is pi by 2 minus theta. That is going to give us the value of x. So x has to be equal to pi by 2 minus 1.2, right? So that is a co-function identity, correct? Because we know it is equals to tan of pi by 2 minus theta is equal to cotangent of theta. That is the identity, correct? So from this identity, we figure out that pi by 2 minus theta should be our answer. So let's use the calculator to find the exact value. Then we are going to match it, right? So we'll do shift pi in this case divided by 2. The value is 1.57, and from there we take away 1.2, and what we get here is equal to 0.37, correct? So 0.37, which is option C, is the right option. Is this clear to you? All right, so that is a very important question from test point of view. Now let's look into question number 6, which says the terminal arm of an angle in standard position passes through the point minus 5, 4. So let's sketch this point. Minus 5, 4 means what? Minus 5, 4 means somewhere here, right? So let's say that is our terminal arm, right? And this point here is minus 5, 4. Clear? Okay. Find the radian value of the angle in the interval 0 to 2 pi to the nearest hundredth, right? So we have to find the principal angle theta in this particular case. That is the case, right? Now, so how can we do it? So we can use the, let's say this angle here is the acute angle alpha, let us say, correct? So we can clearly say that tan alpha is equal to, when we say minus 5 by 4, this side is 4 and this side is 5. So we'll actually calculate positive value, and we know the acute angle has to be positive, correct? So from here we can get tan alpha is equals to 4 over 5, or alpha equals to tan inverse of 4 over 5. Now we have to write the answers in radians. Therefore, the calculator setting should always be in radians for such answers, okay? So we are looking for shift tan inverse of 4 divided by 5, and that gives us a value which is equal to 0.6747, correct? So that becomes the related acute angle. We need to write down the radian value of the angle in this interval, so that is only one angle, to the nearest hundredth, right? So this angle theta is equal to pi minus 0.6747, correct? So we'll take away this angle from pi. Pi minus our answer is 2.4666, correct? We have to round this answer to nearest hundredth. So we'll round this to 2.47 radians. Now radians is a ratio, so even if you don't write radians, it means radians. So I hope that point is absolutely clear, right? Now let's take question number 7. At this stage, I would like you to pause the video, answer the question, and then look into my suggestions. Question number 7. Given cosine theta equals to minus 12 over 3, where theta is between 0 to 2 pi, in which quadrants could the terminal arm be? Determine all possible radian value of theta to the nearest hundredth. Determine all possible trigonometric ratios for theta. So in this case, we know cos is negative in 2 quadrants, correct? So first thing, let's consider this case here. We're looking for a negative value of cosine, right? All are positive here. Sine is positive in this quadrant. Tan in quadrant 3, cos in quadrant 4. That clearly means negative value. We have 2 positions, correct? So in which quadrants could the terminal arm be? It could be in quadrant 2 or in quadrant 3, correct? So both these quadrants are possible. So now, based on this, let's try to solve this. So we have cos theta equals to, if I consider this to be in quadrant 2, I could say this as cos is equal to minus 12, right, over 13. So basically, we are looking into this particular triangle. Let me make a triangle here. We'll keep all sides as positive as we should. So 13 is the hypotenuse, and if this is the angle theta, 12 is this side. So this side here will be 13 square minus 12 square. It's a standard triangle with side 5. You could also verify, what we have here is 13 square minus 12 square, and then square root, what you get, square root of your answer, which is 25, is 5. So we get this side as 5, right? So these are Pythagorean triples, which you should always remember, right? Now, as we say, we have 2 possibilities. One, it could be in quadrant 2. The other, it could be in quadrant 3. So we'll have to work out in both the quadrants separately. Is that clear to you, right? of all the trigonometric ratios. Now let's write down the other trigonometric ratios. So cos theta is minus 12 by 3 is known to us. Now sine theta, if you are working in quadrant 2, sine is positive, so it will be 5 over 13, correct? Reciprocal of sine is cosecant, right? So cosecant theta will be 13 over 5, which will also be positive. Now tan theta is going to be opposite over adjacent, which is 5 over 12, and cotangent theta will be 12 over 5, right? Let me again write cos theta here as minus 12 over 13, and secant theta will be negative 13 over 12, since that is the reciprocal. If we are working in quadrant 3, then tan becomes positive, sine becomes negative. That is the only difference. So in this quadrant, we have sine theta equals to negative 5 over 13. Cosecant theta will also be negative. It will be negative 13 over 5. Tan theta and cotangent theta will be positive values, correct? Right. So, so we should have placed them negative here. Okay. So these are positive values, right? And cosine theta will be negative, secant theta will also be negative, correct? So as you can see, tan and cotangent will be positive for quadrant 3. For quadrant 2, sine and cosecant will be positive, the others will be negative. Perfect. Now let's take up question number 8. A leaning flagpole, 6 meters long, makes an obtuse angle with the ground. If the distance of the tip of the flagpole to the ground is 5.4 meters, determine the radian measure of the obtuse angle to the nearest hundredth, right? So let's sketch the situation. Let's say that's the ground, and we have a pole which is leaning, right? So let's say this is the pole, leaning, right? It's too much leaning, that's okay. And we are given this distance from top is, this flagpole is 6 meters and this distance is 5.4 meters, right? That is what we are given. And what we need to find is this obtuse angle, theta. Okay. So let us first find what is this angle, alpha. Now since we are given side, which is opposite and hypotenuse, we could use sine, right? So we know sine of the angle alpha should be equal to 5.4 over 6, right? So alpha will be sine inverse of 5.4 over 6. So we have to work in radians, okay? So we have shift sine inverse 5.4 divided by 6 gives us a value of alpha as 1.1197, okay? The value of theta, which we are looking for, is pi minus 1.1197. So let's take away this value from pi. So pi minus our answer gives us 2.021. Rounding to hundreds gives the angle as 2.02 radians. So that is the answer for question number 8. So let's take question number 9 now. So I'd like you to pause the video. It's a good question. Try to sketch and then find the answer and then look into my suggestions. Question number 9 here is, the needle of the compass makes an angle of 2.5 radians with the line pointing north from the center of the compass. The tip of the needle is 4.5 centimeters below the line pointing west from the center of the compass. How long is the needle to the nearest hundredth of centimeters? So let's sketch the scenario. Let us assume this is north for us, right? So that is the north. We are given that the needle makes 2.5 radians with the line pointing north, right? So you should know that pi by 2 is 1.57, right? We know that pi is 3.14, correct? So that is how we, so 1.57, this is 2.5, so this definitely is somewhere here in that quadrant, correct? So the position could be shown like this for the compass. Now what the question is saying is that the tip of the needle is 4.5 centimeters below the line pointing west. So that is west. So below this line, that tip is 4.5 centimeters. Is that clear to you? Right? This angle was 2.5 radians. We need to now find the length of the needle. How long is the needle to the nearest hundredth of centimeter? So this length is what we need to find. So let us figure out first the acute angle alpha here. Acute angle alpha will basically be equal to 2.5 radians. Take away this pi by 2, right? Pi by 2. Which is same as 2.5 take away 1.57. Right, so let's use calculator. So we have 2.5 minus 1.57, which gives us 0.93, right? So approximately 0.93. Now, in this triangle, we have the opposite and the hypotenuse, and therefore we could use sine alpha, right? So sine alpha is opposite side over hypotenuse, which is 4.5, and the length which we need to find. So length L is equal to 4.5 divided by sine of this angle 0.93, correct? So we have 4.5 divided by sine of 0.93, which is 5.613. 5.613, correct? We have to round our answer to the nearest hundredth of a centimeter. So that means 5.61 centimeters, right? So that becomes the length of this particular needle. So I hope that is absolutely clear. Now let's look into question number 10, right? Which is also the last question. Solve the equation 4 sine square x minus 3 equals to 0 in the interval 0 to 2 pi. So we have the equation 4 sine square x minus 3 equals to 0. That means sine square x will be equal to 3 over 4. Correct? Take it to the right side, divide by 4. Sine x will be square root of 3 over 4. Remember to write plus and minus. So whenever you do square root, you have to write plus and minus, which is plus minus square root of 3 over 2, right? So in this particular interval, which is from 0 to 2 pi, we have how many solutions? We'll have 4 solutions, correct? So we are looking for 4 solutions in this case. The solutions are, remember the triangle. Square root 3 over 2 means we are looking into this triangle, which is pi by 3, pi by 6, and pi by 2 triangle, right? Sides will be 1 to square root 3, correct? Since sine value is square root 3 over 2, the angle x is, the acute angle, is what? Pi by 3 in quadrant 1, correct? So from this angle we are looking at, so it is pi by 3. So that is one of these angles, right? So what we have here is pi by 3. So that becomes, we are looking for 4 solutions here. So these are the 4 solutions, correct? So one angle is pi by 3. The other angle will be 2 pi by 3. And then we have 3 pi by 3. This one is 4 pi by 3. And 5 pi by 3, correct? So we have 4 solutions which are pi by 3, 2 pi by 3, 4 pi by 3, and 5 pi by 3, correct? So that is how we are going to solve this particular equation. So I hope that helps. So with that, we have solved a test paper of 10 questions, which will normally take an hour. So with explanation, I think we have done fairly well. I hope you've understood all the processes and simple steps to take care of radian measurements. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.